We're going to continue our discussion of linear function pattern recognition, and our objectives remain the same. We're going to identify linear functions from a table of values. In order to do that, we need to find the rate of change from that table of values. We're taking a look at our whole class practice. So for each table represented below, identify the rate of change and identify the type of function represented. Always to do work in tables, you are going to start with finding your change in x and your change in y. So to do your change in x, you are looking at from 6 to 7, are you increasing or decreasing, and by how much? So from 6 to 7, I'm increasing by 1. That's why it's a plus 1. My y values are going from 12 to 18. So if I look at my number line over here, you can see that it is over on the right, and to go to 18 would be going further to the right, so that is increasing by 6. I want you to do that for the rest of the table. So when you look at your table, if you look all the way down, 12 plus 6 is 18, 18 plus 6 is 24, and if you go all the way down, your change in y is increasing by 6, and your change in x is increasing by 1. And so all down here is increasing by 1. So because these values are the same, I know that my rate of change is constant. So I want you to write this on your paper here too, that this is constant. And then we'll write what that is. And remember that the rate of change is the change in y, so 6, over the change in x, which is 1. So my rate of change is a constant 6 over 1. Now remember, we defined unit rate as having 1 per 1, or 1 in the denominator. And so my rate of change is already in a unit rate form. So I can just write that as 6 over 1. And because my rate of change is constant, I know that this is a linear function. We'll take a look at our change in x for the second example. And so you're going to do the same thing. 3 plus what gives you 4? It's plus 1. You're going to go down your list. You're going to do the same thing for your change in y. This one could be a little trickier because we're introducing some negative values. So I strongly encourage you to use the number line. So if I'm looking at -6 right here, and I need to go to -3, -3 is over here. So I'm going to the right. So that's still increasing. That's going to be an increase of 6. So please continue your table. So if we look here, our change in x's continue to increase by 1. Our change in y's, we have from -6 to -3, like we showed right here, was increasing by 3. But from -3 to -1 was only increasing by 2. From -1 to 2 was increasing by 3. That's right here. And then it was increased by 2, by 2, by 2, and then by 3. So what we have here is we don't have a constant rate of change, because we have a change of 3 over 1, then 2 over 1, then 3 over 1, then 2 over 1. We have 2 different rates of change that you see in our table. And so this is not constant. If it is not constant, we know that it is not linear. This is a non-example. So this is not linear. So because we had different rates of change, it was not linear. We call this a non-example. We call this a non-example because it is not linear. This is an example. This is a non-example because it's not a linear function. For our last example here, I want you to do the change in x and the change in y like we just did. So you can see in our last example, the change in x is increasing by 1, and the change in y is decreasing. These values are getting smaller, so that's why I have a subtract right here. So you can imagine, it doesn't fit on our number line, but our 100 would be way over to the right, and we'd go to the left to 80 and to the left to 60, and so that's why it's subtraction. You can see that we have the same values here for the change in y and the change in x, so this is constant, so that it would be a linear function. So negative 20 over 1 is the same. Our unit rate is the same as our rate of change because the change in x was 1, and of course that's linear. So a quick summary of what we did today in your notes. The rate of change is often abbreviated ROC, that the ROC, or rate of change, is the change in y over the change in x that you find in your table, and that the linear functions have a constant rate of change. And what that means is that it has the same unit rate for the whole table, which in this example, all of our change in x's were 1, which meant our unit rate and our rate of changes were the same. But in future lessons, you will see how this comes into play. So we have 2 examples of linear functions. This was a linear function, this is a linear function, but this was a non-example because it did not have a constant rate of change. It had some 3 over 1 and some 2 over 1.